Hello guys, welcome aboard. I'm going to be tackling the web application basics from the Cybersecurity 101 learning path. This is a new path from TryHackMe. I am around like 2 hours. I have 2 hours left to complete most of the modules to actually receive tickets. So I've decided to try to complete as many of them as I can. This is gonna be taking almost 2 hours, which to be honest, I don't think it's gonna take me that much amount of time given my background that I actually built web applications with the framework that I use called Ruby on Rails. So I am fairly versed with basically web applications. So I will just skim through the basics, you know. I will just do it just to complete the module. Do it as fast as I can, so do not expect me to actually read everything here. I will just go fast. That's it. That being said, let's get right down to it. Okay. Welcome to Web Application Basics. In this room, we'll walk you through the key elements of web applications, such as URLs, HTTP requests, and responses. This is perfect if you're starting and want to get a handle on the essentials, or if you're looking to build or work with web apps. By completing this room, you will understand what a web application is and how it runs on a web server, break down the components of a URL, and see how it helps access web resources, learn how HTTP requests and responses work, get familiar with different types of HTTP request methods, understand what different HTTP response code means, check out HTTP headers work and why they matter for security. Mhm. Okay, web application overview. Consider an analogy of one application is a planet. Astronauts travel to the planet to explore its surface, similar to how someone uses a web browser to explore or browse a web application. Although we only see the surface of a planet, a lot is gone under the surface. You can imagine the whole planet is a web server with many things going on under the surface of the web server, yet all we can usually see is the surface of web pages or apps. We'll now explore the various components that make up a web application. Front end. Frontal can be considered similar to the surface of the planet, the parts that an astronaut can see and interact with based on the laws of nature. A web application will have a user interact with it and use a number of technologies such as HTML, CSS, and JavaScript. HTML is basically just a markup language where you just structure the web page. CSS, let's just say that CSS adds the colors to the web page, and JavaScript adds the functionalities that you may have, right? I'm not gonna read through all on each of them. Then the backend, right? The backend of a web application is things you don't see within a web browser, but are important for the web application to work. On a planet, these are the non-visual things, the structures that keep buildings standing, the air, and the gravity that keeps feet on the ground. Yeah, so we have the database. There are many other infrastructure components underpinning web applications, such as web servers, application servers, storage, various networking devices, and other software that support the web application. On our planet, these are the roads that are present, the cars that run on those roads, the fuel that powers the cars. WAF Web Application Firewall is an optional component for web application. It helps filter out dangerous requests away from the web server and provides an element of protection. This could be considered similar to how a planet's atmospheres can protect inhabitants from harmful UV rays. There are many components involved in delivering web application front-end components like this, focus on experiences like browser backends such as web server, database, web, are the engine under the surface. Which component in the computer is responsible for hosting and delivering content for web applications? The web server, right? Which tool is used to access and interact with web applications? Front, what? Which tool? What do you mean, which tool? Front end. There must be a tool. Infrastructure. Which tools used to access and interact with web applications? Come on. Which component acts as a protective layer, filtering incoming traffic to block the firewall? The firewall that you mentioned here. Web application firewall, is that it? Yeah, web application firewall. And then which tools used to access and interact with web applications? The web browser, I would say. Yeah, uniform resource locator. Okay, uniform resource locator, URL is a web address that lets you access all kinds of online content, whether it's a web page, video, a photo, or other media. It guides your browser to the right place on the internet. So this is the scheme, the user, the host domain, the port, the path, the query string, the fragment. Think of a URL as being made up of several parts, each playing a different role in helping you find the right resource. Understanding how these parts fit together is important for browsing the web, developing web applications, and even troubleshooting problems. Here's a breakdown scheme. It's the protocol used to access the website. The most common are HTTP and HTTPS. HTTPS is more secure because it encrypts the connection, which is why browsers and cybersecurity experts recommend it. Websites often enforce HTTPS for added protection. The user, yeah, host domain, yeah. the port, the path, the query string, which protocol provides encrypted communication to ensure, we just read it, HTTPS. What term describes the practice of registering domains names that are misspelled, variations of popular websites to exploit user errors and potentially engage in fraudulent activities? What term describes the practice of the script? Oh, that would be what host domain was important type of squatting. This is the one. What part of a URL is used to pass additional information such as search terms for input query? Query something. Query string, right? Yeah, HTTP messages. HTTP messages are packets of data exchange between a user, the client, and the web server. These messages are very important for understanding how web applications work because they show how users' requests and the server responses are communicated. Yeah, okay, so yeah, HTTP request and there's the HTTP response, right? Start line headers, yeah, the headers are made up of key value pairs that provide extra information about the HTTP message. They give instructions to both the client and the server handling both the request or response. These headers cover all sorts of things like security, content types, and more, making sure everything goes smoothly in the communication. What is this empty line? Empty line is a little divider that separates the header from the body. It's essential because it shows where the headers stop and where the actual content of the message begins. Without this empty line, the message might get messed up and the client or server could misinterpret it, causing errors. But in the body is where the actual data is stored. Yeah. Which HTTP message is written by the web server after processing the client's request? Is returned by the web server. Oh well, it would be HTTP response, right? What follows the headers in an HTTP message? The body. Oh, the empty line. Sorry. Without the empty line, things get messed up. The next one is HTTP request line and methods. Get user login HTML, HTTP1, the version. Okay, is what a user sends to a web server to interact with a web application to make something happen. Since these requests are often the first point of contact between the user and the web server, knowing how they work is super important, especially if you are into cybersecurity. Okay, imagine an HTTP request showing the key parts like the method, the get post, yeah, login, and version HTTP 1.1. These elements make up the basic of how client user communicates with the server. Method, path, yeah, sure. HTTP methods, get, post, put, delete. Yeah, get is to actually fetch something. Post is to when you want to change data. Put is when you want to update data, similar to post, but different. Delete is to remove. Patch is updates part of a resource, right? Head works like get but only retrieves headers. Options tells you what methods are available for a specific resource. Trace, connect, yeah. URL path, yeah, this is the URL path. Tells the server where to find the resource the user is asking for. Yeah, okay. HTTP versions or multiple versions, okay. Built on HTTP but uses a new protocol quick for quicker and more secure connections. Although HTTP 2 and HTTP 3 offer better speed and security, I have never actually used them, I think. Many systems still use HTTP 1.1 because it's well supported and works with most existing setups. However, upgrading HTTP 2 or HTTP 3 can provide significant performance and security improvements as more systems adopt them. Which HTTP protocol version became widely adopted and remains the most commonly used version for web communication? Uh-huh. Um, Known for introducing features like persistent connections and chunked. Well, it's the first one, right? Yeah, which is HTTP request method describes the communication options for the target resource, allowing clients to determine which HTTP methods are supported by the web server. I don't know. I think it's one of these two. So, which request method describes the community for the target resource, allowing clients to determine which HTTP methods are supported by the web server? Which HTTP request method? Patch. No. Candy patch. Trace. Connect. It's not a common, but it's critical for introducers. What methods are available? What they can do with the server? Yeah. What was it? Options, right? Yep. Yeah. In an HTTP request, which component specifies the specific resource or endpoint on the web server that the client is requesting, typically appearing after the domain name in the URL? Which component? Well, it's Which component specifies the specific resource or endpoint on the web server that the client is requesting, typically appearing after the domain name in the URL? Is that the HTTP method? No, it's only three. URL path, yeah. Yep. HTTP request headers and body. Request headers allow extra information to be conveyed on the web server to the web server about the request. Some common headers are as follows: host, user agent, further, cookie, information the web server previously asked the web browser to store is held in cookies, content type. Describe what type of format of data is in the request. Okay, request body. Post and put where the data is sent to the web server as opposed to requested from the web server. The data is located inside the HTTP request body. The formatting of the data can take many forms, but some common ones are URL encoded, form data, JSON, XML, URL encoded, application, okay, this one here. Form data, multi-part form data. Upload, profile. API, JSON application is formed. They can be sent using the JSON JavaScript object notation structure. Data is formatted in pairs, value, multiple pairs are separated by commas. Yeah, sure. Which HTTP request header specifies the domain name of the web server to which the request is being sent? The request header, that would be the host to which the request is being sent. Yeah, what is the default content type for form submissions in an HTTP request where the data is encoded as key value pairs in a query string format? On multi-part form data, is that it? I don't think it is. So, oh, key pairs. Yeah, this one. Oh, this one. Okay, which part of an HTTP request contains additional information like host, user agent, and content type guiding how the web server should process the request? That would be the content type. Is that it? Nope. What are you asking me? Sorry. Which part of an HTTP request contains additional information like host, user agent, content type? Are we talking about the application XML? No. XML formatting? Form data? No. What? These are two words. The first one is contains 7. Which part of an HTTP request contains additional information like host, user agent, content type guiding how the web server should process the request? That would be content type. Okay. No, I don't think it is. The request headers, is that it? Yeah. Next one is HTTP response status line and status codes 200, 500, 404 not found. 200 is successfully retrieved. When you interact with a web application, the server sends back an HTTP response to let you know whether your request was successful or something went wrong. These responses include the status code and a short explanation called the reason phrase that gives insight on how the server handled your request. Okay. HTTP version just tells you the version of the HTTP status code, 3-digit number showing the outcome of your request, reason phrase, a short message explaining the status code in human readable terms. Okay, this is informal responses from 100 to 199. This codes means the server has read parts of the request and is waiting for the rest. It's a keep going signal. Successful responses 200 to 299. This codes means everything worked as expected. The server processed the request and sent back the request data. 300 to 300 disco tells you that previous user requester has moved to a different location, usually providing the new URL. For 400 to 499, request problem with the request, maybe the URL is wrong, or you're missing some required info without authentication, and server error responses. This cause means the server encountered the error while trying to fulfill the request. These are usually server-side issues and not the client's fault. Okay, 100 continue to 100. Okay, 301 moved permanently, not found. Internal server error. Makes sense. What part of an HTTP response provides the HTTP version, status codes, and a brief explanation of the response's outcome? Recent phrase. What? I just read about it. Recent phrase. Is that it? No. What part of an HTTP response provides the HTTP version? What part of the HTTP response? Mm. Status line. Yeah. Which category of HTTP response codes indicates that the web server encountered an internal issue or is unable to fulfill the client's request? 500, right? So internal server error. Okay. Which HTTP? What? Which category of HTTP response codes? Oh, it's server error responses. Okay. Which HTTP status code indicates that the requested resource could not be found on the web server? 404. Not found. HTTP response headers and body. Yeah. When a web server responds to an HTTP request, it includes HTTP response headers, which are basically key value pairs. These headers provide important info about the response and tell the client, usually the browser, how to handle it. Picture an example of an HTTP response with the header highlighted. Key headers like content type, content length, and date give us important details about the response the server sends back. Okay. Require response headers, date, content type, server, other common response headers, set cookie, cache control, location. Okay, which HTTP response header can reveal information about web server software and version, potentially exposing it to security risks if not removed? Um, that would be um, server. Yeah, which flag should be added to cookie in the send cookie HTTP response header to ensure they are only transmitted over HTTPS, protecting them from being exposed during unencrypted transmissions? Which flag? Secure, and the secure flag, right? Which flag should be added to the cookies in the set cookie HTTP response header to prevent them from being accessed by a JavaScript? This one here. On to the next one. Security headers. Yeah. Let's quickly skim through this. HTTP security headers help improve the overall security of the web application by providing mitigations against attacks like cross-site scripting, clickjacking, and others. We will now dig deeper into the following security headers: CSPs, content security policy, strict transport security, X content type options. You can use a site like this to analyze the security headers of any website. After the discussion in this task, you will hopefully have a better understanding of what it reported on. Let's check it out. So I just want to analyze the security headers, enter address here. I will enter my personal website and see what up. Scan your site now. Ooh, content security policy, permission policy. Okay. Solid, great. Let's perform a deeper security analysis for your website and APIs. Okay, that was unexpected. Okay. What was I? Where was I? Okay, here. To analyze the security headers of any website, after discussion this task, we will hopefully have a better understanding what it is reporting on. So it is content security policy. What does that mean? A CSP header is an additional security layer that can help mitigate against common attacks like cross-site scripting. Malicious code could be hosted on a separate website or domain and injected into the vulnerable website. The CSP provides a way for administrators to say what domains or sources are considered safe and provides a layer of mitigation to such attacks. Within the header itself, you may see properties such as default source or script source, defined, and many more. Each of these give an option to an administrator to define at various levels of granularity what domains are allowed to what type of content, for what type of content. The use of self is a special keyword that reflects the same domain on which the website is hosted. Looking at an example, CSP header, default self, script self, yeah. CD and TryHackMe assigns self. Okay, we need the use of default source, which specifies the default policy of self, which means only the current website. Script, which specifies the policy for where scripts can be loaded from, which is self, along with scripts hosted on CD and TryHackMe. Style source, which specifies the policy for where styles used as style sheets can be loaded from the current website itself. Okay, that's interesting. I didn't know that. That's something I just learned. Okay, strict transport security. The which one more? Permissions policy, right? So script transport security here ensures that web browsers will always connect over HTTPS. Yeah, let's look at an example. Yeah, makes sense. X content type options. The X header can be used to instruct browsers not to guess the mime. I don't know how you pronounce that. Time of resource, but only use the content type header. Here's an example. Here's a breakdown of the X content headers by directions. This instructs the browser not to sniff or guess the mime type. Right? Referrer policy. This header controls the amount of information sent to the destination web server when a user is redirected from the source web server, such as when they click a hyperlink. The header is available to allow a web administrator to control what information is shared. Here are some examples of referrer policy. Here's a breakdown. Which one? Permissions policy. Where's that? Where's the permissions policy? There's no permission policy here you're talking about. In a content security policy, configure which property can be set to define where scripts can be loaded from. Script source. When configuring the strict transport security header to ensure that all subdomains of a site also use HTTPS, which directive should be included to apply the security policy to both the main domain and its subdomains? Include subdomains. This is the one. Which HTTP header directives use to prevent browsers from interpreting files as different MIME, type on what is specified by the server by mitigating, type sniffing, MIME, I think I saw this here. What's it? No sniff. Okay, next one, practical task. Making HTTP requests. Let's click on view site just to tackle this real quick. This is an emulator for making demo HTTP requests. Turgay, would you like to guide to learn more about how to get started? Not really. So, okay, what do I do now? Okay, this is making HTTP request. What you learn from the desk above. Complete the questions below. In case the static site is not visible, click the view. Okay, make a GET request to API users. Okay, API users. Go. Okay, we get this. What is the flag? What is the flag? You tell me. This one. Okay, next. Make a post request to API user 2. Okay, so let's just click post API users 2. Then go. And then what's the flag? Cannot find page. Hey, cannot find the page. API user. Only user. Not plural. Go. Yeah. Successfully updated. Okay, and update the country of Bob from UK to US. And update the country of both from UK to US. How do you expect me to do that? Enter key. Oh, country. And then the value. US. Save. Proceed. Go. Oh, you have modified user data. This was fun. Make a delete request to API. Okay, let's close this. Close this. Make a delete request to API user 1. To delete the user. What is the flag? Let's delete the user. You have just deleted the user. Oh, fun. So good. Conclusion. That's it. You have completed the test. Quick composer involved in web applications with structure of uniform resource locator or an HTTP request. Yeah, sure. I mean, it was fun. Come on. What do I get? A laptop? I mean, I'm just missing one, guys. This happened also the last time I went through a cybersecurity ticket thingy. Uh, if I go to my profile, I click on view profile, as you can see, I have I have already won the unredeemed these tickets. That's streak freeze and blah blah blah, and I have two of all of them. So just one $10 swag or just try have me t-shirt, whatever, just give me whatever. Last time I didn't earn anything. But yeah, let's keep going, right? A 12-month premium voucher should be fun. I would rather have the DEFCON though. They only have 10 trips that include everything, I think. Okay, we'll see. Let's keep going, guys. So this was it for this module. Thank you for sticking up with me. I will be continuing uploading some more videos about TryHackMe and potentially Hack the Box in the future. As for now, this was it. Thank you. Have a good one, guys.